So the lab number 1 we'll be dealing with we'll be looking at the solutions, we'll be looking at the diffusion, we're going to look at different solvents, polar versus non-polar. So a few terms we already discussed. Solute is the substance that is being dissolved, and solvent is the substance which is dissolving the solute. The solvent quantity is usually greater than the solute. So when solute particles are moving through the solvent is diffusion. Diffusion is the movement of particles from a region of high concentration to a region from low concentration. Polarity, an equal sharing of electrons within the molecules with polar covalent bonds, which results in a molecule with partial positive and negative charges. What is polar? Non-polar molecule in our example will be cyclohexane. The polar compounds can in general dissolve in water. Non-polar solvents dissolve non-polar solutes. Like dissolves like. So in the first experiment we're going to do 12 clean test tubes, put 2 milliliters of water in 6 tubes, put 2 milliliters of cyclohexane in other 6, and then place a few crystals, place these compounds into water and in cyclohexane. So I've got 2 rows, water in front, cyclohexane in the back, and we're going to start working on adding the chemicals. Mixtures are prepared, the solutions are prepared, and now let's take a look at the results for each individual solute. So sodium chloride, polar salt, completely dissolved in water. Now what about cyclohexane? You see there is a precipitate at the bottom, which means it does not dissolve as we could expect. I'm trying to raise it up a little bit, but there is a precipitate at the bottom. So sodium chloride does not dissolve in cyclohexane, which is not surprising. Copper sulfate, completely dissolved in water, polar salt, not surprising. And it remains at the bottom, no diffusion, no solution, nothing like that, in the non-polar cyclohexane. Now iodine is a non-polar molecule, and as you can clearly see, it remains undissolved in water. It gives water a little bit of a brown color, but that's about it. But look how beautiful the iodine solution in cyclohexane is. You see, it's dark purple. The lighting doesn't allow us to fully appreciate this. So non-polar iodine, here you go. What about lard? So you can see the chunk of lard floating at the top of water, and I couldn't even get it off the wall of the tube. And what about cyclohexane? No traces. Lard, basically animal fat, fully non-polar animal fat, fully dissolved in the non-polar cyclohexane. Next one is corn oil. You can see corn oil on top of the water, this little bubbles floating, so it cannot dissolve in water. But if you look at cyclohexane, here you go. There are some traces that you may see, but generally speaking, corn oil perfectly well dissolves in cyclohexane. And finally, sucrose, table sugar, okay, fully dissolves in water, no traces of the crystals. Now you can see at the bottom of the tube the precipitate with the sucrose. So sucrose, being polar, does not dissolve in cyclohexane. So now you can fairly easily answer the questions here: which substance is dissolved in water and which substance is dissolved in cyclohexane. Now, based on the concept that polar dissolves polar and nonpolar dissolves nonpolar, you can and you should classify these 6 substances as being polar or nonpolar. So go ahead and do that, and that'll be it for the lab number 9.